Okay, let's continue with SQL and look at some more SQL commands. Again, just like the lectures, this is the video link, and please watch it, then do the PowerPoint in animated mode. There's some class participation docs in Blackboard lectures. Please try to answer before you see the answer in the PowerPoint. There's an assessment, and you can apply these concepts towards the homework or lab. So SQL, Structured Query Languages, this is a DBMS software. And through the SQL commands, you can actually create tables, your database, and they will be residing on the disk of the DBMS server computer. Some examples of DBMSs are Oracle is not only one, Microsoft SQL Server, MySQL, and some others. And through them, you actually run the SQL commands and your tables will be created. We are going to use, for examples, relational, the schema. So my database contains relation sailors, key, sailor ID, sailor name, rating, and age. Boats, key, boat ID, boat name, color, reserves, sailor ID, boat ID, and the date. What I have done, I actually ran these and I created a table. So again, I want to show you this is the schema, and this is the actual SQL that I executed, and again, straightforward. These are SQL comments. And I think they are very welcome before you run SQL or look at SQL. So here's my drop table, sailors. Again, if this has foreign keys pointing to it, cascade constraints will actually allow you to delete the parent table. And here's our create table, sailor ID, name, rating, and age, just like there. Integer, varchar 10, integer real. Primary is SID, and I'm also adding a check to make sure that the rating is only between 1 and 10, an integer. I did run this, and this is what you'll get when you execute this command. I inserted tuples, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tuples that I inserted. Here is the execution of these inserts one by one. If I select everything from sailors, here are my 10 tuples, here is my relation instance. I do the same thing for the reserves table. Again, using the keyword cascade constraints will allow me to delete in case there are other tables that point to this. So reserves has SID, BID, and date. Please note that date is a built-in data type. Primary key are the 3 attributes, and here are the inserts. And if you select everything from reserves, that's the content. I'll do the same thing for the boats. Boat ID, boat name, color, primary key, boat ID, and I'm going to insert 4 tuples. And if I do a select everything from boats, these are my 4 tuples. So you can do look at the class participation just to challenge yourself. You don't have to turn it in. It's practice. So look at the aggregate operators. So count everything, count in this column. So again, this is an attribute in your table. So sum, average, max, min are some of the aggregate operators you can use using SQL. So given the sailor instance, for example, if I select the name from the sailors, which is this relation, where the rating is equal. Now, this is an inner query. It will be executed first. So this is going to select the max rating from sailors. And if you visually, you can see the max rating is 10. You are going to use that 10. So you're going to return the name or names of the sailors with rating 10. And if you look manually, you can see that I have 2 tuples in my output relation, Rusty and Zorba. I did run this to prove to you that it works, and this is what I got. What about select count everything from sailors? Yes, very good. It's going to return how many tuples are in sailors, and if you run this, you'll get a 10. There are 10 of them. Now, please note that I could actually rename this to something that I want using the as or the equal. Okay, more example of aggregate operators. What about if I want the average age of sailors with rating 10? Again, there are many ways to do it, but let's look at some. So the rating is 10, that's the condition, and I want the average of age of the sailor with rating 10. Pretty straightforward. I did run it, and this is the output. What about average age of distinct sailors with rating 10? I can actually use the distinct keyword, and this is the example average, and I want the distinct. Okay, so that's the only difference between the two of them. What's this doing? Select, this is my sailor instance. Count distinct ratings from sailors for all sailors with name Bob. I only have one Bob, so what would be the count? Okay, just one. Okay, so there's only one sailor. Okay, what about find the name and the age of the oldest sailor? Again, this is the process. First of all, you need to figure out your output relation, how many attributes, two of them. So that is select these two. From, you have to figure out how many relations, just one, the sailors, and the condition is the, so this is pretty straightforward. So I want the name and the max age from sailors, but to figure out the oldest sailor, I need a group by, and I'll introduce that shortly. But you need an inner query, so if I get the max age from the sailors, and I'm going to see that the age is equal to that. So let's introduce some new concepts. So you can see that gave you an error. So let's look at group by and having. So we apply aggregate operators to all the qualifying tuples. But what if I want to create groups? So for example, if I want to find the age of the youngest sailor for each rating level, again, possible from 1 to 10. Again, that's cumbersome to do. You maybe go in a loop for loop, and you go from rating 1 all the way to 10, and you actually are going to find the age of the youngest for each. But that's cumbersome. So these are the two more constructs we introduce. So syntax select from where, and the next two will be, and this is an example, group by. So this is, for example, I'm going to group by rating 1 through 10. And this is the having count greater than 1. That's the qualification that will discard the group, not just the tuple. So again, this is the target list. This is your output relation, the attributes. The grouping list has to be contained in the target list. So I think that is straightforward. Again, when you have more than one relation in the from cause, you actually do a cross product. So when you evaluate, so this is the join operator in the relational algebra. Again, these qualifications in the where and having, you are using the select operator. And again, to just get the attributes you're interested in, you use the pi or the project. So this is very, very powerful. Let's answer this question. Find the rating and the age of the youngest sailor with age greater or equal than 18 for each rating with at least 2 such sailors. Now, again, I'm going to actually disqualify Zorba because he's 16. I'm trying to answer this manually. So I need two, at least two for the rating. So this is what I have. So this is just one, that's just one, and 10 is just one. So the only group that I have that has at least two such sailors is the rating 7. And what I'm interested is the rating and the age of the youngest. Okay, so 7 and 45, so it's going to be 35 between the two of them. So this is my output relation. If I were to write a SQL for it, so here is the SQL by using the having, we did it manually. Okay, so let's look at it. So I want to select the rating and the minimum age from sailors where. So the first disqualifies the age that's not greater or equal than 18. I'm going to group by rating. So I have groups of 1, 8, 10, 7. But I'm going to disqualify the ones that the count in the group is not greater than 1. And doing it manually, we did notice that we only have 1. So again, I'm executing that command, and this is what you have. Okay, let's answer this question. For each red boat, 102 and 104 are red. Find the number of reservations for this boat. So the reservations are in this table. So I want for 102, that's 1, 2, 3. For 104, that's 1, 2. 102, 1, 2, 3. Okay, very good. But again, I mean, you can see all um, the joins and all the conditions, but this can be done simple. So here's both ID 102, 104, and the count would be 3 and 2. And we did it manually. Let's see the SQL for this. My output relation will have two attributes. So here is 104, the two of them. So I'm interested in both ID, and again, I can rename this attribute using the as. So I'm going to count. So the count for 104 was 2. The count for 102 will be 3. How many tables are involved in this? So I need the sailors and boats and reserves. Actually, I don't need sailors. Why do I need sailors? I guess to join on SID. I think maybe we don't need sailors. For sure, we need the boats and the reserves. Okay, so the where condition, I have the R reserves BID is the same with boats BID. And the color is red, and we are going to group by BID, and out of that group what we want to return is the count in the group. I think this is very, very, very powerful. Okay, what about this? Find the age of the youngest sailor. You can take this instance, for example, with age greater than 18 for each rating with at least 2 sailors in it. So let's look at the, so the upper relation will only have the age, right? So let's look at the, I need at least 2 sailors. So if you look at rating 1, there's just 1. Same for 9, and I have 2 for 3. I have 2 for 7, and I have 2 for 8, and I have 2 for 10. So these are my groups by this is an inner query. So I'm going to select the count from sailors where the rating is equal to the rating in the inner query. So this S rating, that's why you need the range variable. So this is another instance of the reserves table. So this has to be greater than 1. So 1 less than. What I'm interested is just the age, but I think it would be useful to also return the rating. So this would be the output, so rating and the minimum wage. So I have the 4 groups, and what I'm going to calculate is the minimum age for, we discover is 3 and 7 and 8 and 10. That is very powerful. That tells you that actually when you write is like write a program that does this and that, you actually have to test it. You maybe have to answer the questions manually to verify your answers. Okay, another question. Find those ratings for which the average age is the minimum over all ratings. So again, you cannot use 2 aggregate operators one after another. So again, this has to be done in steps. So I'm going to create a relation and temp, and I'm going to put the average age that is the result of executing the select. And as you can see, even the group by can have an inner query. So this is my intermediate table that I'm creating. So again, I'm not saying you'll be able to write this without spending some time in writing it. Okay, null value represent unknown. Now that is a problem because in SQL, null creates a kind of a problem. So what's the semantics of the null? Again, checking, for example, if rating is greater than 8, true or false when the rating is null. How would you answer that? The same thing, you have a null, an and, or not connective. So again, it's a little bit challenging where you have true, false, and unknown 3 values instead of a Boolean. So again, these are the challenges on using the null. Okay, let's review integrity constraints. When you insert, delete, or update, the DBMS will check the constraints. Again, your application cares for the semantics. The DBMS software will only enforce the constraints that you have specified. They are the domain constraint, that means the type that you provided for that field or column. The values that you put in there have to match the type, and that's pretty good. Primary key constraints and foreign key constraint. Again, primary key, if you have a relation, all the tuples have to have different primary key. Foreign key constraint when you have the children pointing to the parent in another table. So domain is pretty easy to actually enforce by the DBMS. Now I can specify some other constraints. So let's look at this constraint where I use the check. So here's my table sailor, a simple constraint that I can, this is a keyword. I want the rating to be greater or equal than 1 and less or equal than 10. Rating is an integer. So that's pretty simple. What about if I have a constraint like the interlake boats cannot be reserved constraint? I can actually have name constraints. So here is my constraint. I give it a name, no interlake reserved. And I'm going to check. I'm going to select from the boat's name. And again, if they have to be different than interlake, then I'm going to look in the reserves and only get the name, but they cannot be interlake. So that's a pretty powerful constraint that you can set. Okay, so interlake is 101 and 102. And I cannot. Can I have constraints over multiple relations? Yes. So this is an example. Here is the check. And I'm going to select the count from sailors plus the select the count from boats has to be less than 100. I'm not sure if this is matching the real reality, but this is an example of a constraint over multiple relations. Now it's possible that the count for sailor is 0 and 0 plus the count of boats it will be less than 100. So now to actually, again, this is not supported, but SQL provides what's called an assertion. So you give a small club, and you take this check, and you make sure the select count from sailor plus select count from boats is less than 100. Again, that will not be working on all the DBMSs. Now, this is a heavy-duty concept, the concept of a database trigger. So it's a procedure that will automatically start running inside a DBMS based on an event. So the trigger has three parts. Is the event that will activate the trigger. Now, there's a condition that will actually trigger the event, and this is the action that you have to do when the trigger is activated. So the action, we'll look at some examples of actions. So the condition. The condition a trigger can be true-false statement. And how do you get a true-false? For example, if you execute a query that returns true. Or if you execute a query that returns false. For example, you do a select, and if you don't find anything, you return nothing, that will be false. If you return some tuples, that will be true. The action. Let's look at what kind of actions. Triggers are used maybe to alert users of unusual events. What kind of events? Database events. The only events you can have in the database is insert tuple, delete tuple, and update. So this is an example where you have a customer that places an order, and you keep track of that customer's past purchase history, and you realize that he qualifies for a discount, and that will fire the trigger, and the action is to sell the item cheaper. Another use of triggers, logging the events, auditing purposes, and security checks, where I would say HIPAA and maybe some other laws requires you to log every access to the database and put it in the log table. So these inserts, update, deletes will actually generate an entry in the log table. Or you can use, every time a customer places an order, you can create a record with the customer ID and current credit limit and insert this in a customer history table. So there are many uses for triggers. Or statistics on how many table you accessed and what you have modified. So triggers are very useful. Let's look at some examples of triggers. So again, this is the event, this is the action. So let's break this down. Create trigger are keywords. Okay, so keyword before insert on, these are keywords, and this is your relation table. So this trigger called init is going to initialize count to 0. Okay, so the event is before you insert on students, you want to initialize this count to 0. Now, please note the syntax. This is a programming language. It's called PL/SQL if you talk about Oracle, or T-SQL if you talk about Microsoft SQL Server. So again, you have to use the keyword declare, and this is how you declare variables. So here is variable of type integer, and begin end, you actually put the code. So it's assignment statements, you have loops, you have if then else. It's a regular programming language. Now the trigger, you have to use the slash to specify that that is the end of the trigger. Now let's look at another trigger that increments L count. I guess that's a C. It looks like an E. Okay, so create trigger keywords. The event after insert on students. So these are keywords, and this is the relation. So every time you insert in students, If so, when the new age is less than 18, you are going to increment, the action is you increment the count by 1. So this trigger will actually be fired every time you add in the student's tuple where the student's age is less than 18. So you can keep track on how many students with age less than 18 you have. This is the whole syntax for create trigger. So create, if you want to, actually if you have and you want to delete it, you can use create or replace trigger. So all these are keywords. This is the name of your trigger. And again, you can have the event before, after, and you can use or. So this is an example: create or replace trigger, print salary changes, before delete or insert or update on employee table. When the you have a employee number, you check, make sure it's different than 0. So you are going to calculate the difference between the new and old salary, and you are going to display the difference. So every time you change an employee's salary, you get this display. Again, please note this is in PLSQL. This is how you send things to, let's say, system.out print line. So it's dbms underscore output dot put. This is an assignment statement, and this is an or instead of the plus in Java, but it's pretty intuitive in what this trigger does. Okay, so Oracle, Microsoft SQL Server. Okay, let's look at another example of a trigger. You have a trigger called Young Sailors Update. Create or replace trigger are keywords. You want to, after insert on, this is your relation sailors, for you want to, here is begin end, this is your code. You want to insert into Young Sailors. Young Sailors has the schema, a sailor ID, sailor name, age, and rating, so it has 4 attributes. So what you want to do is select from original sailor the tuples that qualify, the ones that have age less or equal than 18. So your young sailors relation will be the same schema as the sailors, but it will only contain the sailors whose age is less than 18. Now, what I'm going to go over next is actually see these in action. So here are the sailors. So I select everything. These are the 10 rows in sailors. So I'm going to create my young sailor table, the one that will only have the less than 18. And then I'm going to create, so I can, young sailors, the same schema as sailors, SID, name, age, rating, primary key, and the rating. Okay, so this is the actual execution of the create table. And if I select everything from young sailors, it should say 0. Okay, here's my trigger, create or replace trigger, the one that I showed you, young sailor update. After insert on sailor, I'm going to insert into young sailors the same thing if the sailor has less than 18. Remember the slash. I run this, and you get this trigger created, so this compiled and successfully. Now I want to fire it. So what I'm going to do, I'm going to insert into sailor values 99, Vic, 3, age is 18. And my trigger should be fired. The only problem is I need to use the new and old to actually read and write the variable at the same time. So while I'm reading from young sailors, I want to write, so I use the syntax new, SID, new, so that is the value that comes from the sailor table. So let's redo this, and let's run it. So when I insert into sailors, here's the row that, but since this is 18, when I actually select from young sailors, I should see that tuple in there, and indeed is in there. So that's pretty cool. So I'm sure we can manage that new that allows you to read and write. Another trigger example. So I have a table T2, I have a table changes, and what I want to do, I'm going to, so create or replace trigger, that's the name of the trigger. After update on T2, I want to insert into the changes the old and the new value and the user that made the change. So that's pretty cool. In my table changes has 1, 2, 3 attributes. So this is the new value, this is the old value, and this is the user that made that change. So after I create a table, and again, please remember the slash, and after you run this, so all the changes to table T2 will be logged with the old value, the new value, and the username that changed it. So if I actually want to trigger that, and I want to see what's in the changes table, so I'm going to insert into T2 values 2. So if I select now what's in changes, I can actually get that tuple. The old value was 3. And this is the 3, the new, okay, so I updated it. Then this is the user that made the change. So that triggers are pretty much fun. So what we have learned about SQL now can actually be challenging. SQL allows you to specify rich integrity constraints. Some are checked by the DBMS. You can do checks, assertions, and one of the most useful parts of the SQL language are the triggers, which are probably programs that are running as the result of a database event. So we looked at several examples. Okay, well, enjoy it, and please apply these concepts towards your lab, and have fun.